All right, so welcome back. Remember this Friday, you've got your first design document draft due. This is one of 6 or 7 drafts that you'll be doing throughout the semester. And so we wanted to take this opportunity to talk to you about technical writing and our expectations for that design draft. And J.C. Andrews from an associate director in the Writing Center has graciously agreed to come and help me with this lecture. This is a lecture that we've given several times over the years in coordination with the Writing Center, because it is a great resource for students to use that are having trouble getting better at writing. So with that, welcome and thank you for coming in.
Thanks for having me. I'm JC. Hi. I am a second year creative writing PhD, and I'm also an associate director of the Writing Center. So I'm here to talk with you all a little bit about technical writing processes and techniques that we practice in the Writing Center that might be useful to you in your field. So first, we're going to talk a little bit about the job market and some of the competencies that are important to some of these respondents. In particular, critical thinking and problem solving, professionalism and work ethic, and oral and written communications. So as you can see here, about 95 to 100% of these respondents see these skills as essential, but only about 40 to 55% of people within the job market are rated proficient in these skills. So we're hoping that we can talk through some of these skills and help you develop them a little bit today, and that they'll be transferable throughout the time you spend here at UNL and beyond when you're looking for jobs.
And I'll add that our industry advisory panel, which is local and regional employers that come in and advise us on our curriculum, they've echoed the same things, that things like technical communication skills are very, very valuable, but even graduates don't possess them all. So if you can, even if you can just write a decent email that is clear and concise, right, you're putting yourself above a lot of your peers out there. So technical communication is an extremely valuable value-added skill to the rest of your skill sets.
Great. Yeah. So the agenda for today, we're going to do 3 things. We're going to start off with a free write and think about the parallels between coding and writing. Then we're going to do some reverse outlines and talk about how they can help you learn to code. And then we'll analyze the design document that you'll be working on and talk a little bit about how they communicate your code. So we'll start off, like I said, with the free write, thinking about the parallels between coding and writing. So in writing, good code is like writing a novel. The author posits that the process of writing code and the process of writing a novel are similar. In one section, the author focuses on drafts. So I want you to think about how you draft an essay, or any piece of writing for that matter, and think about these questions. So what are the steps you take to get from an idea to a final draft? And then how are these steps similar to your coding process? So I want you to take about 4 minutes to write through your thoughts on these questions, and the only rules for a free write are just to keep writing. So keep typing or keep your pen moving, whichever one you're using, and we'll come back in about 4 minutes to discuss. take a couple more minutes. Okay, maybe go ahead and start wrapping that up. So does someone want to talk through their response to the first question? So what are the steps you take to get from an idea to a final draft?
Heard a lot of typing. Somebody wants to share something that they've typed. Yeah, go ahead.
If I'm writing like a paper, what I would usually do is like in my head I have a general idea of what I want, like not anything like fantastic, but like just something.
Right.
Then I just like write down like, okay, here's what I want to do, here are the things I want to talk about, maybe like a thesis statement.
Ah, okay.
Maybe here's some arguments I want to use, and then maybe make a first draft out of that. Now, again, it'll be bad,
Sure.
but it's at least something.
Exactly.
And then you just reiterate and reiterate until you finally get like something that you can reliably say, this can be called a final draft.
And once you've got all those things, then you can start organizing and arranging them into something called an outline, right?
Yeah.
Yeah, you also had your hand up. Go ahead.
It was pretty similar. Create an outline first, and then pieces, your 3 points, and then you go from there.
Okay. Yeah, go ahead.
You can start by writing, writing the draft, like getting all your basic ideas down. Doing more drafts, you're writing more ideas, refine, you might find other ways to get your point across.
So some of those initial ideas that seemed good at the time then become passé, or they become subsumed by better ideas, right? Good. Any others?
Yeah.
I do a lot of that stuff, but the one thing that I always do is I try to keep one constant document going. I'll make saves throughout the writing process, but I like to keep all of my thoughts on pretty much one file so that I can kind of just keep everything organized as I go without having to hunt down different ideas on different documents and different papers.
Good. And what tools do you use to do that?
For me, I mean, I've used Word. I've done in an internship before. We've had to do like mechanical engineering drawings and documentation, and so we'll use various tools that are industry standard for mechanical engineering. I can't remember the specific names, but for me personally, I just do Word.
Sure. Okay. And in computer science, what is our main tool for doing that you've been using? Hopefully since you started, but certainly for the last 3 weeks. Your IDE, but where do you keep your versions of your code? Git, exactly, right? And that's Word has a history, and you can track changes and stuff like that. But Git is on a whole other level. And when I write everything in LaTeX, and it's all plain text documents. And I use Git to keep track of all of those versions, because you can always go back to something else, like 2 versions ago or something. Good.
Yeah, so we started talking a little bit about it just now, but who can talk me through their response to the second question? So how are these steps similar to your coding process?
Yeah.
Kind of like my writing process with coding, I like to have everything kind of separated out. That way, like, say, a function that takes in a file and, like, processes it, if that thing later down the line breaks or is poorly made, or I need to, like, update it, I don't need to, like, deal with a bunch of spaghetti code, because, it's out there and it's not, like, in the middle of everything.
You've organized something into an isolated module that you can do unit tests on, that you can isolate that behavior over here, so if it needs to be updated or fixed, you're only focusing on one part of it at the time. Right?
Great. Yeah.
I like to get like the main idea across, get it like working, get a solid version, and then remove unnecessary sections. Get it down.
Yep. Editing, right? Cutting out the cruft at the very end, but also making it more efficient. We call that, in computer science and coding, we call that refactoring in some ways. You go back and it works, but you've got a lot of unnecessary stuff in there. So you go back and you refactor it so that you're not changing the behavior, but you're making it a little less brittle, you're making it a better design. One thing I want to say about this process is the free writing, when you're doing it like in a creative writing assignment or a 5-paragraph essay or something, it's designed to get you started, right? Get you over that hump to break writer's block. And you all have that with coding too, right? The most common complaint that we hear from students is, I don't know how to get started, right? Well, how do you get started? Start free writing, right? Start blasting down ideas onto that paper. Right, and that just gets you started. You'll find like 5 things that I wrote down are utter trash and garbage, but that 6th thing that I wrote down, I'm going to go ahead and go with that. That got the ball rolling, right? That got the entire process started. And so free writing in coding and in any endeavor is intended to break that writer's block and get you started.
Mm-hmm. Yeah, I want to say too that you'll be surprised by some of the ideas that you run into when you free write. So it's a good practice. Okay. So we're going to talk a little bit about reverse outlines now. So how do you make a reverse outline? You usually start with a complete draft or an almost complete draft, and then you summarize the function of each paragraph or section in 1 sentence or less. And you'll also number your paragraphs. So who can tell me what the function of this first paragraph is in 1 sentence or less? Yeah.
Just kind of like a statement of intention, I guess.
Yeah,
Like,
right.
I am ready to apply this, and eventually get the purpose.
Yeah. Introducing yourself and your purpose to the reader. Great. What about this second paragraph?
Basically, here's what I've done. This proves that I can actually do the thing.
Mm-hmm. Yeah, so your qualifications, right?
Yep. Why I'm qualified for this job. Right?
Mm-hmm. Great. Yeah, so this is how reverse outlining works, and I'll pass it over to you.
Sure. So here's a problem, right? It's called the suffix array problem, where you're given a string or you're given a long sentence or something like that, and you've got to compute all the suffixes. For example, if the word were science, right, all the suffixes are, well, the word itself is a suffix, but then if you take off the first letter, then that's a suffix. If you take off the next letter, that's another suffix, until you get down to the last letter in the word. Then you need to sort it, right? And then you usually put this into a data structure like a binary search tree or something like that. But it has a lot of applications both in natural language processing and in DNA processing and stuff like that. And so here is a piece of code that solves that problem, right? Now, a piece of code is kind of like a letter or a bunch of paragraphs, right? In fact, in my CS1 class, we always draw parallels, right? Periods, that ends a sentence, right? And so semicolons end a statement, right? Or white space in Python. You chunk code, right? You chunk code into this chunk, this chunk, this chunk, and then you put white space between it because those are your paragraphs, right? So outline this. Just take maybe a minute or two to outline it. Identify what the major parts are and then what their function are, just like we did for those two paragraphs. We'll go ahead and give you a minute. All right, so if you were to outline this, how many main points would there be? 3? All right. So what's the first one? Anybody? What's the first item, I guess, in the outline? No? How about you?
Creating a new list and adding all the suffixes to it.
All right, good. Right, and that you broke that up into 2 subpoints, right? So I would agree with that there's one main chunk there, right? And then there are 2 parts to it. You're creating a new list, and then you're iterating through all of the suffixes and adding them to that list. What's the second one? That's pretty obvious because it's good vertical or white spacing here. It's been chunked for you, right? So what's the second one? Yeah, just sorting it, right? You're just sorting the suffix list. And then the third one is you're printing it out so that you can see it in the standard output, right? And that's exactly what the outline would look like this, right? With that main point, with 2 subpoints. So in an outline, of course, you would have one, and then you would indent stuff for subpoints. You would indent stuff for subpoints, etc. Right? This is also a piece of code that solves the exact same problem, and it does work. Right? So take a minute to outline this one. Okay, it's only been 30 seconds. Are you going to be able to do this in 1 minute? No, why? Way too much, right? So the thing with reverse outlines is that if you can easily do a reverse outline, that means that the draft is probably good, right? That you don't have a lot of repetition, that you don't have a lot of superfluous stuff, that it's nice and concise, and it's clear and straightforward, right? If you can't easily do a reverse outline, like with this code, it's probably bad. Right? Now, critique this code. What are some bad aspects to it? If you were grading this, right, or if you submitted this, what would you expect us to hit as graders? Yeah.
Documentation.
The what?
Documentation.
What do you like? What?
Some comments or something.
Like for example, like these comments up here.
Yeah.
So what do we call that? They obviously put that in as a poor man's debugging at some point, and then they just commented it out in the final version, but they didn't get rid of it. What is that called again? Cruft, exactly, right? What else is bad about it? Yeah.
But like very bit of like the for loop inside the for loop suffix I plus suffix j is just not
Yep.
a good way to do that. You
Yep.
just do a substring.
A for loop within a for loop is never a good idea, hopefully, as you all realized with your first assignment, right? Now, these are small enough that it's not going to matter that much as far as efficiency, but there are better ways of doing it, right? What else? So if you don't notice, well, what about these variable names, I, J, K? Should they be declared at the top? No, they should be scoped as small as possible, but also, do you ever see K being used? Unused variable names. What is temp and temp2 and temporary, right? Are those ever used? I don't think so. Maybe one of them is used, but no, not generally. What else do you see? So I see repetition. What it's doing is that it's actually splitting it apart and then putting it back together and then splitting it apart again, right? And if you had gone through a 5 or 10 minute process of reverse outlining, you would have realized that one of these chunks is repeating operations, right? Do we need to create a string here just so that we have to print it out, right? And then append this end-line character? No, right? So again, this was bad code, right? And this was a combination of 3 bad submissions from many years ago that actually solved this problem, right? So I took the 3 worst submissions and I put them all together. It wasn't just one submission that was bad, but it had all the aspects of bad code that I would want to highlight in a critique, right? All right, so, yeah, go ahead.
Yeah, so in any piece of writing, you're always going to want to think about what you're writing, of course. Who are you writing for? Who's your audience? And why is it important to you? And why should it be important to your audience? So I want you to maybe take a couple minutes to respond to these questions in relation to your design document. Take about 30 more seconds. All right, you can go ahead and start wrapping that up. Does anyone want to run us through their responses?
So what are you writing in your design document? Or what, if you have not read the handout yet, which you should be doing either today or tomorrow, and we'll go over that here in a second, what do you think you are writing in your design document? Yeah.
Descriptive document that describes the intentions of my code in human readable way.
Okay, good. All right. How about who is it, or it should be whom is it for?
For the assignments, my grade stays up.
Okay, it is definitely for this class, but you should be taking a more, like you should be treated as a real document, not just an assignment. And we'll be looking for writing that conforms that way, right? That you should be treating this as a real process, as a real project that you're doing for a real client. So who is it for? It's not for the class. It is, of course, in the end for your grade, but also it is for a technically competent audience, because in the real world, when you write a design document and you hand it off to another team, they're the implementation team. They're going to take that design and they're actually going to implement it, right? It's not for a client. You're not going to give it to the client and said, here's our design, right? The client, there's a different process called the requirement solicitation, where if you're talking to a client, what are your requirements? What does this project need to do, right? And then they communicate that back and forth is for requirements. Then the next step is design, where you're designing. We've already done that for you, by the way. And then the next step is for design for the actual implementation. How about why is it important? Yeah.
It's important because it builds skills in all sorts of fields, from like technical skills to critical thinking.
Yep. You get some experience. Oh, so one, you get experience with technical writing, which is going to be super important in your careers. Two, for this course, we're forcing you to think about the design 1 week before it's actually due. Your design document is due this Friday. Your phase 1 is due next Friday on the 13th, right? And if you, we've talked about technical debt before, right? If you don't do it right the first time, you'll have to find time to do it over, right? That you're basically taking out a loan on your future time if you don't do it right. But if you, this is the opposite. If you invest time up front with a design, right? And you think about the design, you refine the design, and you get feedback from us, right? Then that means that your design is going to be much more solid going into the actual implementation, right? Now it's kind of like MC Escher's drawing of design informs implementation. Once you get to the implementation, you realize, oh no, there was a design flaw. I need to do it a different way. So you go back and you redo the design. It's a never-ending cycle of process, right? All right, so where would you go if you didn't know these answers? So, GitHub with your actual assignment, right? And again, this is something that you should be reading for today and tomorrow, right? We'll go to Campus Wire here in a second. But the design document should be a clear, comprehensive enough that a reasonably technically competent person could reproduce your system design, though not necessarily every detail, with identical functionality without access to your actual code base. Right? Now, the key here is the technically competent person, right? You are not writing and saying, oh, in Java, you type this out and then you end every line with a semicolon, right? A technically competent person would know that, right? In fact, you're not even going to write about Java at all, because it could be that this technically competent person that is reproducing your design is using C# and a .NET stack instead, right? You're not going to be very detail-oriented. You're going to keep things abstract, right? All right, what do we have there? This is an actual example. This is, I think, from Deloitte, which is a software engineering consulting firm. And this is an actual design document that I took many years from. I never worked for them, but I found it as an example. So tell me about this technical document here. What do you notice first? You don't have to read it, right? Just look at it, you know, very high level, abstractly. Yeah.
It's organized in like certain topics.
Yeah. So complete organization, section 2, 2.1, 2.2. Within those sections, how are they organized?
Based on
How about the formatting? How is the formatting organized? Do you see a lot of text here? Does this look like a novel to you? No. What have they done?
Made an outline.
Made an outline. They've used bullet points instead, right? Not only that, but they have repetition here. Repetition is good in technical writing because it keeps things in a consistent format. Requirements phase, during the requirements phase. System design phase, during the system design phase, et cetera, right? It is not meant to be a bestseller, right? It is not meant to be engaging writing. It is meant to be dry. It is meant to be straightforward. It is meant to be comprehensible and technical. That's what technical writing is all about, right? That was just a zoom in on there. All right, later on in the document, there's something that looks like this. You'll find out what this, in fact, you'll be producing something like this. It's called an ER diagram, entity relation diagram, right? And what about text here? How much text is there in the description of their database? One line, right? One sentence that says, look at the diagram, right? Remember, it's a technically competent audience. Somebody who's technically competent in database design would be able to look at this and immediately reproduce it in code. Right? They would immediately be able to tell what are the primary keys, what are the foreign keys, what are all the tables, what are the fields in the tables, right? If I were to describe this in equivalent text, I would have to write out 2, 3, 4 pages, single spaced, right? Do you want to read 4 pages of technical dry documents like that? No. A picture is worth 1,000 words, right? Literally in this case, it is worth 1,000 words. Right? A big giant 4-page text has been replaced with a diagram. Okay. All right.
Yeah. So we'd love for you to come and see us in the Writing Center. We're located in Andrews 102, so it's on the first floor, and there's a big sign on the outside, so you can't miss it. We offer one-on-one sessions with graduate consultants and undergraduate consultants for writing in any discipline or any stage of the writing process. So whether you're brainstorming, organizing your ideas, or polishing a final draft, come see us. We're happy to talk with you. And you can also bring in non-academic writing as well. So like resumes, CVs, things like that. If you're working on a job application, we do job applications all the time. So literally anything. And we have 3 types of appointments. So we have online appointments. Those are video chat appointments. Then we have email feedback appointments. So how those work, say you have an appointment from like 6:30 to 7 p.m. You upload your document the day of. Someone will comment on your document during that appointment time, so from 6:30 to 7. And then at 7 p.m. on the dot, you'll have that feedback back. You can go to UNL, MyWC Online, to book an appointment. And this is actually wrong, so we do 25-minute and 50-minute appointments. So you can do either one of those. So what to expect and prepare for when you have an appointment. Like I said, bring anything. You can bring anything in. If you just have ideas, that's great too. We can work with you on that. Any feedback you have, any drafts you have, any questions you have. So just bring whatever you have related to the assignment or the project that you're working on, and we'll go from there. I also have bookmarks, sorry. I have bookmarks up here with all of this information on it, and a QR code. So if you want one of those, come see me after class.
I would add that they don't do proofreading for you, or at least that's what they've told me in the past. Right? They're there to help you actually write, not to do your busy work of making sure that you spelled everything correctly. That's what spell checkers are for. Or that you have correct grammar on everything, or punctuation, right? They're not there for proofreading. And the second thing I would add is absolutely take advantage of cover letter and CV or resume feedback. In February, we're now in February. In a couple weeks, or maybe it's 1 week from now, we will have our spring career fair. Even if most of you are freshmen, even if you're in your first semester, it is now time to start, getting practice talking to employers. right? Even if you're not looking for a summer internship, which you should be anyway, right? Look for an internship, have as many internships as you can, because it's your way of getting to know companies, getting to know how careers actually work. Right? You get to know the companies that you would want to work for. You get to know the companies that you don't want to work for, right? And you get paid throughout the entire process, because there's no such thing as an unpaid internship in computing. So make sure that you're getting to the career fair, and to bolster your chance of getting an offer or getting your name out there, make sure that you've got a really good resume and a really good generic cover letter. And the way that you can do that is by getting feedback from the Writing Center. Right?
Yeah, I want to add too, we do accountability appointments as well. So what those are, you just come in either online or in person, and we sit with you, set your intention for the time, and then we work together. Also, I have done like mock interviews with people during appointments, if that's something that would be helpful too.
Cool, mock interviews. I didn't know that they did that, but neat. At this point, what I want to do is I want to get more specific, right? So first of all, here is the project overview. This is something that you should be reading today and tomorrow. It covers the entire project for the rest of the semester, right? So don't think of it as, oh no, I can't do this in 1 week. No, you're not going to do it in 1 week. You're going to do it over the next 12 weeks, all right? There's, I guess this is, this is the project overview. So it basically goes through what the business is that you're building the system for, what the system and the scope is, et cetera, right? And then we break it down into phases. You got 7 phases here. In the next 2 weeks, you're doing phase 1. You're doing EDI, electronic data interchange here. Now, how do you know what to expect for this Friday? Well, here is a template that we give you. This one is in LaTeX. You don't have to use LaTeX unless you want to. We've also got a Word version that you would use, right? Right? You would, change this project title, right? Don't leave project title. Don't leave the square brackets there. Those are placeholders. Provide a short abstract, right? What we're looking for, and then here's the outline, right? You're not going to write all of this, because we haven't even covered databases yet, right? So you're not going to be writing this entire document. You're going to be writing the most relevant parts to phase 1, which are outlined on CampusWire. What are we expecting in the first draft? We're expecting the introduction. In other words, have you read the handout for the project? Tell me who the client is. Tell me what their business is. Tell me how their business operates. You should have a start on section 2, the overall design, right? And you're going to come back and you're going to change it, because you're going to be adding things and different components as you go through this process. We would expect a sketch outline of section 3.2. What data classes are you going to be implementing in this first phase in order to do the electronic data interchange? You're going to be reading from a CSV file. You're going to be reading it into, creating your objects, and then you're going to be persisting your objects out to a JSON or XML or both, if you want bonus points, format, right? And what are those formats? Well, don't worry about it. You're going to be using a library to do it, okay? All right, so any questions? Otherwise, did you want to hand those out, or you want to come down and get them?
I don't know if I'll have enough for everyone, but
Okay.
if you do want one, come see me and I can give you that.
And I thank JC again and the Writing Center for helping me today. We'll go ahead and return back to Java and object-oriented programming on Wednesday. All right. Thanks.
Thanks.